Hello students, today we will study the chapter measurement, a fundamental concept in physics. Every scientific observation and experiment depends on correct measurement. Without accurate measurement, no calculation or result can be trusted. So let us learn the idea of measurement, its instruments, its errors, and the rules used in scientific calculations. Measurement means comparing a physical quantity with a standard unit. Every measurement has two parts, a magnitude and a unit. For example, if we say 8 meter, then 8 is the magnitude and meter is the unit. These standard units help scientists everywhere follow the same system. There are two major types. Direct measurement, measured directly using instruments like meter scale, weighing balance, or stopwatch. Indirect measurement, calculated using formulas. Examples include density, velocity, volume, and area. These cannot be measured directly. Instead, they are derived from other measurable quantities. Different instruments are used depending on accuracy. 1. Meter scale least count equals 1 millimeter. 2. Vernier caliper measures internal diameter, external diameter, and depth of objects. 3. Screw gauge measures very small thickness such as wire diameter. 4. Spherometer measures radius of curvature of spherical surfaces. The least count of a vernier caliper is least count equals 1 main scale division minus 1 vernier scale division. Usually, least count equals 0.01 centimeter. Measurement formula. Reading equals main scale reading plus vernier scale reading multiplied by least count. Because of its precision, it is commonly used in school and college laboratories. A screw gauge is used when very high accuracy is needed. Least count is calculated as least count equals pitch divided by number of head scale divisions. A typical least count is 0.005 millimeter. Measurement formula. Reading equals main scale reading plus head scale reading multiplied by least count. Mass is measured using a beam balance, physical balance, or electronic balance. An important fact is that mass does not depend on gravity. So your mass on Earth and your mass on the moon will be exactly the same, although your weight will change. Time can be measured using simple clocks, wall clocks, stopwatches, quartz clocks, and atomic clocks. Atomic clocks are the most accurate, with an error of only 1 second in 3 multiplied by 10 raised to the power 7 years. This extreme accuracy is used in satellites and navigation systems. Least count is the smallest measurable value an instrument can measure. Common least counts: meter scale equals 1 millimeter. Vernier caliper equals 0.01 centimeter. Screw gauge equals 0.001 centimeter. Stopwatch equals 0.01 second. Understanding least count helps us estimate accuracy and possible errors. Every measurement contains some error. The types are systematic errors, predictable errors due to poor instrument calibration or wrong technique. Random errors caused by unpredictable fluctuations like reaction time. Gross errors, human mistakes such as careless observation or wrong recording. Zero error happens when an instrument does not read zero at the zero position. Positive zero error, instrument shows a positive value when it should be zero. Negative zero error, instrument shows a negative value. Correct reading formula. Correct reading equals measured reading minus zero error. When we take repeated measurements, we calculate the mean value by adding all readings and dividing by the number of readings. Absolute error equals magnitude of mean value minus each individual reading. Relative error equals absolute error divided by mean. Percentage error equals relative error multiplied by 100. These help us understand the accuracy of results. Significant figures show the precision of a value. Rules. Non-zero digits are always significant. Zeros between digits are significant. Leading zeros are not significant. Trailing zeros are significant only in decimal numbers. Examples: 0.0045 has two significant figures. 230.0 has four significant figures. For rounding a number, if the digit is less than 5, keep the previous digit unchanged. If the digit is greater than 5, Increase the previous digit by 1. If the digit is exactly 5, round only if digits follow after it. Correct rounding helps maintain meaningful significant figures. Error rules depend on the mathematical operation. For addition or subtraction, total error equals error in A plus error in B. For multiplication or division, fractional error equals fractional error in A plus fractional error in B. For a raised to power n, fractional error equals and multiplied by fractional error in A. Main scale reading equals 3.4 centimeter. Vernier scale division equals 5. Least count equals 0.01 centimeter. Final reading equals 3.45 centimeter. Main scale reading equals 2.5 millimeter. Head scale reading equals 25. Least count equals 0.005 millimeter. Final reading equals 2.625 millimeter. Three readings are 10.2, 10.4, and 10.3. Mean value equals 10.3. Absolute error equals 0.066. Percentage error equals 0.641%. Zero error equals plus 0.04 centimeter. Measured reading equals 3.50 centimeter. True reading equals 3.46 centimeter. These concepts form the base of all scientific measurement. Accurate measurement ensures accurate results in every experiment. Revise these rules carefully and practice numerical questions to strengthen your understanding. Jai Hind.